Hello, everyone. My name is Vijay Samuel, and I'm the Observability Architect at eBay.
Hello, all. I'm Sandeep, and I'm the tech lead for the Observability platform at eBay.
Today, we're going to spend the next few minutes to talk about how we are scaling our SLI SLO initiative inside of eBay, the things that we do to push our observability platform to its limits. Let's go through some fast facts first. Talking about the scale at which the observability platform at eBay runs, we have 2.5 million Prometheus endpoints that are being scraped at any given point in time, which roughly translates to 58 million ingested series per second, which in turn translates to 2.2 billion active time series. And these time series are helping power around 9,500 queries per second, which help doing things like alerting, recording rules, and things like that. A quick refresher on what SLIs and SLOs are. An SLI, or a service level indicator, is a quantifiable measure of service reliability. And SLO is a service level objective that is the target of an SLI over a period of time. It is an internal promise to meet customer expectations. So a simple formula to compute an SLI would be the total number of good events divided by the total number of valid events times 100. Internal to eBay, we have the concept of platform metrics. So every eBay application, specifically the ones that power the eBay site, are built on top of what are called managed frameworks. So the managed framework is available in languages like Java and Node.js, and it offers a standard set of utilities that help the eBay developer do their job easily. And any changes into these managed frameworks are delivered monthly, and it targets more than 7,000 applications that are there. So what we have done is we have added some standard instrumentation into these frameworks so that it can help standardize things like SLI, SLO, so that they can be onboarded across all applications inside of eBay. So what are the metrics that we instrument? CPU is an example, memory, garbage collection, the total number of requests that are being processed by the application, and the request latencies.
One of the challenges we face in computing SLIs is the sheer scale we operate at. Let's quickly take a look at the numbers we operate with. We have over 7,000 applications in eBay, and each of them emits golden signals. The cardinality of these golden signals exceeds 150 million. This presents a significant challenge when attempting to run the PromQL queries to compute SLIs. PromQL, as we know, it runs on a single coroutine. This means attempting to run a PromQL to compute SLI across 7,000 applications would be pretty much impossible. And to illustrate the scale of the challenge, consider the following PromQL that computes the 99th percentile of request latency and groups the results by application. This query would require scanning through a vast amount of data to compute the desired result, making it pretty much impractical or even impossible to execute because of the large scale. And to address this challenge, we use something called templated rule groups. In the templated rule groups, this is what we do. We identify all the applications in eBay every few minutes. And for each unique application, we create a rule group, which would have the required recording rules to compute SLI. That means there will be around 7,000 such rule groups, and this would be run across the fleet of rule managers, which will be responsible to running these rule groups, and it will be running it in parallel. And this rule group aggregates the data over the pool, eliminating any instance level metrics, which reduces the cardinality drastically. And this has helped us a lot to compute SLIs in a timely and effective manner, despite the immense scale we operate at. These templated rule groups provides us with several advantages. Since we realize all the applications every few minutes and create a new rule group for each application, every new application created will have the rolled up metrics available automatically without having to manually create the recording rule. Computing SLI over the rolled up metrics is significantly cheaper since the cardinality is much lower compared to the raw metrics. And in most cases, computing SLI doesn't require instance level metric. In eBay, we compute SLIs over 7-day, 30-day, 90-day, and at times even longer duration. And as we know, rolled up metrics have much lesser samples. So computing SLI over longer duration is significantly cheaper when compared to the raw metrics. And the rolled up data is available for any other use case for free. So we use it in many other places. One such example is health-aware rollout, where the rollouts are automatically handled by our system. And if it notices any significant change in the golden signals, then we automatically roll back the code.
To summarize, we do two things to run things at scale. The first one is to standardize the instrumentation from which these SLIs are computed. If they are uniform, then the rollups can happen in a uniform way. And the second thing is the usage of templated rule groups, which allows us to break the problem down into a per application level problem that we can run in parallel to meet the required SLAs when we compute these SLIs. Any questions, we are happy to answer them. And thank you for the time.
Thank you.